Now that we've covered reshaping and transposing, you might be thinking, when would we ever want to use a transpose? It just flips the axes around. When is that useful? Well, that's what we're going to cover in this video. And one of the main use cases for transposing a matrix is the dot product. You might be thinking now, dot product? What the hell is a dot product? Well, let's do what we do. Dot product NumPy. Let's have a research, because this is what we're practicing. Here we go, NumPy dot product of two arrays. Oh, that's not very helpful. Sometimes you'll get that in the docs. It'll give you a very brief explanation of what happens. Specifically, if both A and B are 1D arrays, it is the inner product of vectors. Okay, there's a few text instructions here of what dot product actually is, but let's focus on the code. We'll go back to our notebook. We'll write some code first, and then we'll have a little look into what the dot product actually does. The thing you need to remember with the dot product, it's just another way of finding patterns between two different sets of numbers. So let's start off with a random seed. We'll create two more matrices that we can use for an example. We want this one to be rand_int. Let's make it of size 5 and 3. And we want mat2. Beautiful. We'll just make it the same thing. Random.randint 10 size equals 5, 3. And now we've seen randint before. Do you know what these two lines of code will do? So let's have a look. As a reminder, we can do Shift-Tab. Return random integers from low to high. Beautiful. Let's see these in action. Mat1. Wonderful. Mat2. Even more wonderful. And then we also want to see, we already know the shape, but let's just do it anyway. So we've got the shapes here. Mat2.shape. Wonderful. So in a previous video, we've seen a few different ways of performing arithmetic on matrices like this. One of the ways that we did was multiplication. So we go mat1 times mat2. Let's bring these down so we can see them, because I want to stay nice and zoomed in to keep the code big. There we go, mat1, mat2. Wonderful. This array down here is just going to be the combination of these two multiplied element-wise. 5 times 6 is 30, 0 times 7 is 0. But this is, I said a little tricky word before, element-wise multiplication. There's a few different names for this, but it's mostly called element-wise. Hadamard product. That's how you spell it, I believe. Let's have a look. Hadamard product. NumPy. That's what we're after. How to get element-wise. Yeah, mp.multiply, which is the same as using this little star symbol. So that's element-wise multiplication. Another form of multiplication or product between two matrices is the dot product. So let's have a look at that. Dot product. If we go back actually to our documentation, the formula for doing a dot product is np dot. You could use numpy dot, but we've imported numpy as np. So we're going to do np dot. We want to perform mat1, mat2, which is just our two matrices that we made. So let's run this. Oh, that didn't work. Damn it. Our value error, shapes 5, 3, 5, 3 not aligned. 3 dim 1 does not equal 5. Okay. We go back up to see the shapes of our matrices. They're both of shape 5, 3, 5, 3. And this is saying shapes 5, 3 and 5, 3 not aligned. Well, the difference between dot product and element-wise. So we've seen element-wise before. It's relatively simple. We've got A times E goes into this top left square. A times F. Oh no, sorry. B times F. I just said it's simple and here I am messing it up. B times F. But if we kept going through that, we'd eventually end up with this matrix. But the dot product is a little bit different. Now, we've got, say, a 3 by 3 matrix here, a 3 by 2 matrix here, and we're calling dot on this one with this one. And now, what is going on here? The resulting matrix is going to be 3 by 2, And we have A times J, okay, following along with that. But then we have B times L plus, okay. Then we have C times N. All right, so it's got the top row here multiplied by the first column and adding up the total. And now let's look at a little bit more of a colorful demonstration of the dot product. So here we've got the letters matrix. If we go back here, got the same one as here. Now we've got some color added. This is the top row of the matrix on the left multiplied by the column of the matrix on the right equals this top left square. And then if we kept going through, we would eventually get this resulting matrix here. But there's a couple of rules with a dot product. The numbers on the inside must match. So for a dot product to happen between two matrices, their dimensions, if you put them side by side, so this 3 matches this 3. So this matrix here has 3 rows, and so does this one. And now the resulting matrix is the size of the outside numbers. So the dimensions here are 3 by 2 of this resulting matrix, because the outside numbers of these two matrices are 3 and 2. Okay, so we've got that. For a dot product to happen, the inside numbers must match. Now let's have a look with some numbers that have actually been filled in. We've got 5, 0, 3, 4, 6, 8, and we're calling dot between this matrix and this one. So we've got 5, it's going to come over here, be multiplied by 4. That equals 20. Yep, we've got that. 5, 4. This is A times J. Now we've got 0 times 6. 0 times 6. This is B times L. Yep, we've got that. We're adding that up. Then we've got 3 times 8. This is C times N. All right, and that's 24. And if we added these three numbers together, so we're going to go A times J plus B times L plus C times N. Yep. Beautiful. We get 44. And that's going to fill the top left square of our resulting array. Now, if we went through these two matrices with numbers full and followed the same steps that we've got in this letters matrix, we would end up with something like this. But this is a static demonstration. So let's check out this little beautiful resource here, which is an interactive demo. So this is matrixmultiplication.xyz. This is called the waterfall technique, what this demonstration is going to do. And you can change these numbers here to be something similar to maybe what we've got here, or just to view the process of what's happening. So if we click multiply, it's going to take the matrix that was on the right and put it on top. This is where the waterfall process comes in. Now it's going to flow down. So this row 2, 6, 1 used to be here as a column. And if we add these together, multiply them, we get 15 in the top left. What it's done is it's just replicated this step here. We've got the top left. Now if we follow it through, okay, we get the top right and we get the middle left. Then we get the middle right and the bottom left. And then we finally finish up with the bottom right number. So have a play around with this if you check it out. You can keep going through. It takes a little bit of practice to understand the dot product. Let's go back to our notebook. And now that we know a little bit more about the dot product, we know the rules. The numbers on the inside must match, and the new size of the resulting matrix is 3 by 2 because it takes the outside numbers. How would we make this work with our matrix 1 and matrix 2? If their internal shapes are 5 and 3 and 5 and 3. Or maybe we could use a transpose. Let's try that out. Transpose mat1. Because what does a transpose do? It flips the axes around. So let's go mat1.t. What does that look like? Okay. Might look at that and see maybe it'll work, but let's really confirm it. mat1.t.shape. 3, 5. Is that what we need? Yeah. We need to flip it around. So if we have mat2.shape. Beautiful. So now the inside shapes, if we were to transpose mat1, are matching. So let's do this. or actually before we did np.mat1, mat2. Okay, maybe we transpose mat2. mat1.shape, mat2.t to stay consistent with what we got above. Let's make mat3 equals np.mat1, and then we want mat2.t. So this should work if our shapes are aligned. mat3. Beautiful. And now if we have mat3, what is the shape of mat3? Yes, excellent. So now we can see where the transpose might come into play. If we wanted to do a dot product on two matrices where in our first try the shapes were incorrect, we might want to flip the axes. Of course, you could do this with the reshape as well, but this is just a handy example where transpose comes into play for performing something like a dot product. Now we can see the resulting shape of matrix 3 is the same as the outside numbers. Wonderful. Now, when I first came across dot product, it took me a little while to understand how to actually go through it. A great exercise was to write out a matrix by hand and multiply it and figure something out like this, or use the demo at like matrix multiplication.xyz. The main takeaway from the dot product is that it's just another tool in our arsenal to find patterns between two different arrays of numbers, as we've seen before. Now, in the next section, we'll have a look at where the dot product might be used in practice. So have a practice around, create some matrices, transpose them, see if you can do a dot product, and I'll see you in the next video.